Alright, in this video I want to look at probability through sort of a different lens than how I have in the last few videos. In the last few videos I've kind of focused on the multiplication principle of probability, whereas here we're going to kind of go back to the general idea of probability as being the total number of possible ways that an event can occur divided by the total possible outcomes in general. And so that's going to help us with some of these card drawing problems, which sometimes students find confusing. But I think if you view, again, view your probability as being the number of ways an event can occur divided by the total number of outcomes. Then this probability problem, or these probability problems, become a kind of a counting exercise more than anything else. So let's say we're drawing cards from a 52 card deck, your standard 52 card deck. You got your 13 hearts, your 13 spades, your 13 diamonds, and your 13 clubs, total of 52. What's the probability that you draw exactly 7 clubs? So you reach into the deck, the probability that you draw exactly 7 clubs. Well, our denominator is the total number of possible outcomes. So when you're drawing 7 cards from a 52 card deck, the number of possible ways you could draw those 7 cards is simply 52 choose 7. Now let's look at the numerator. The number of ways that our event drawing exactly 7 clubs can occur. Well, since we're going to draw all clubs, we need to just count how many ways you can draw clubs. 7 clubs. There are only 13 clubs in the deck, so the number of ways to draw 7 clubs, or the number of 7 card hands that are all clubs, is just 13 choose 7. And so I did these on the calculator. This is equal to, the numerator is 1716, and the denominator is this giant number, 133784560. So I'll leave it as a fraction for now. In the end, I'll turn them all into decimals in case you're interested. Let's look at the next one. What's the probability of drawing exactly 5 clubs? Well, again, I write down my numerator again, but the total possible outcomes is still 52 choose 7. And that's still the total number of 7 card hands I can draw. But now I'm drawing 7 clubs. So the number of ways I can draw 7 clubs is 13 choose 5. I think I meant to say 5. 5. I said 7. 13 choose 5. That's how many ways you can draw 5 clubs, rather. But now we have 2 cards left to draw. So I'm going to multiply the number of ways I can draw my 5 clubs times the number of ways I can draw 2 cards from any other suit. So if I throw away my clubs now, because I can't draw any more clubs, I just drew my 5, that means there's only the hearts, spades, and diamonds left. So that's 39 cards, and I need to get my remaining 2 cards from them. So it's 39 choose 2. And this turns out to equal 1287 times 741 divided by that giant number again. And this actually ends up equaling 953667. Alright, how about this next one? What's the probability that you draw exactly 4 clubs and 2 diamonds? So once again, the total number of hands I can draw is 52, choose 7. Now I have to get exactly 4 clubs. So getting exactly 4 clubs would mean I need to count the number of ways I can get 4 clubs. That's 13, choose 4. And now I have to multiply that times the number of ways I can get 2 diamonds. Well, there are also 13 diamonds in the deck, so the number of ways I can get 2 diamonds from them is 13, choose 2. And now what's left? I've only drawn at this point 6 cards, so I have 1 card left, and it has to come from the other 26 that I haven't drawn from. So that would be 26, choose 1. Alright, and so I'm going to just go right to the answer this time. Multiplying that out gives you 1, 4, 5, 0, 0, 2, 0, divided by our good old friend 52, choose 7. Alright, and let's finish with the last one. What's the probability of getting no clubs? Well, that means all your cards have to come from those 39 cards in the deck that are not clubs. So that means that you just have to take your 39 non-club cards and choose 7 of them. And if you do that out, you get that in our numerator and that in our denominator. So we can leave our final answer as fractions, but sometimes we put them into decimals just to get a good sense of how likely it is, right? It's not always easy to find, what percent of this total here is 1716. So I did it out in the calculator. These are about equal to, this one's crazy, 0.0000128. That's that first one. This one here is about equal to 0.00713. A little more likely, but still very unlikely to get exactly 5 clubs. And the second to last one looks like this is about equal to 0.1052. So you have a roughly 10% chance of getting 4 clubs and 2 diamonds. And for this last one, the probability of getting no clubs, that's roughly 0.1150. So a roughly 11% chance. Alright, so hopefully this video helped you understand that probability can be viewed often as the number of ways a number of ways an event can occur divided by the total possible outcomes. And drawing cards from decks is usually a classic example of this approach to probability.